All right, so this is the second video for week 11 on structural assortativity for CS 499 Network Science with Dr. Vigil-Hayes. So in the last video, we introduced the concept of structural assortativity. And this is where nodes tend to form links to each other based on similarities or differences in the structure of their neighborhoods. So for example, we talked about assortative networks, which is where hubs, nodes with very high degrees, tend to link to each other. We also talked about a different class, disassortative networks, where hubs tend not to link together. So again, this would be where nodes with high degrees tend to not form connections to each other. And then we also talked about neutral networks. And these are networks where nodes with a high degree sometimes will link to other nodes with a high degree, but sometimes they'll link to nodes with a low degree. So there's really not a correlation between the node's neighborhood structure or its hub, its role as a hub, and its tendency to connect to other types of nodes. So in the next few videos, we'll keep talking about different ways to determine which class different networks belong to. And this first technique that we're going to go through is kind of a visual way of setting up a matrix so that you can maybe start to discern whether or not a network belongs to one of these three classes. And so using a matrix, one of the ways that we can examine the assortativity class of a network is to look at how many times nodes with different degrees tend to form connections with nodes that have a certain degree value and ordering the matrix categories by degree size. So if we were to look at this matrix that we have, we kind of see that there's a y-axis and an x-axis, and these are just going to be on both axes all degree values that are in a network, and they're ordered from lowest to highest. And what you can see is that for this particular network, we have something emerging that looks like a positive slope. So this is a heat map. So the darker colors represent a higher frequency of occurrence, and no color means that there's no connections between nodes that have these different degree values. So when we start to observe a positive slope like this, what that means is that nodes with high degree tend to form more connections to other nodes with a high degree, and nodes with a low degree, like the green nodes in this kind of sub-diagram under the matrix, nodes with low degree tend to form connections with other nodes with a low degree. So for this example, with a positive slope, we would call this assortative network. So this is where nodes that have similar structures tend to form links to nodes that look kind of the same as themselves. All right, so the next example would be a node that has a negative degree, a negative slope when we're looking at the degree interaction matrix. So again, interestingly, if we were to just look at the degree distribution between these two networks, we would actually find they were identical degree distribution. So exact same degree distribution, just how the nodes tend to link to each other based on their structures is exactly the opposite. So here we have a negative slope in the matrix, which means that nodes with a high degree tend to more frequently form connections with nodes that have a low degree, and nodes with low degree tend to form connections with nodes that have a high degree. And so this would be a great example of a disassortative network. So after looking at the assortative and disassortative network example, there's also kind of this middle ground. And again, this network has exactly the same degree distribution as the other two networks, but when we put it into the degree interaction matrix, we find that there's neither a negative or positive slope that emerges. And there's no clear assortative or disassortative characteristics. And so we call this type of network a neutral network. And this just means that there's really no trend that dictates whether or not hubs are more or less likely to connect to each other. So this is just the first initial quick technique for determining which class a network falls into, assortative, neutral, or disassortative. And in the next few videos, we will be exploring some more systematic and precise methodologies for determining which class a network belongs to.